Nope.
That that's a rather expensive solution.
All right, we should be live. We're alive. There we. Wait, what? No? Huh? Maybe a
Are you
pause.
getting noped by YouTube?
It says that we're waiting for the episode. Oh, there it is.
Okay.
I see. Existence has been confirmed.
Yay?
Yay!
Yay.
Um, People are arguing about dwarves. So here's the rule as an editor. If you're writing an article for me on Universe Today and I am your editor, the plural of dwarf, of red dwarf, is dwarfs. So there are
Yes.
2 red dwarfs, 3 red dwarfs. If, however, you're referring to fantasy creatures, then it is dwarves. So,
Yes.
so you
That
got,
is the
and that's how you tell the difference between stars and and mystical people from Tolkien's realm.
it is true. It is true.
Yeah, we actually have a style guide. I haven't actually included that in the style guide, but I will for Universe Today. So any new writer who joins us, they get. Nancy wrote the style guide and has all these. Like the one that's pretty tricky that takes people a little while to understand is just about moons, the moon, the
Oh
universe,
yeah.
universes, the solar system,
When
right?
do you capitalize
When do you capitalize and
what?
when do you not? Yeah, yeah. And so it's we have it's very specific that
It's
yeah,
all trickstery.
yeah. If you're talking about the moon, then it's lowercase t, uppercase m. If you're talking about Jupiter's moon, Europa, then it's lowercase m, moon. If you're talking about other moons, lowercase m, right? There's only one moon, ideally with the moon. And then Earth, like other Earths, super Earths, those are, and other solar systems are lowercase when we're talking about our solar system. So,
It's trickstery.
yeah,
That's all I've got.
yeah.
The
And
the one that broke me is if you ever get E.B. White's style book, it's quite good. It's quite small, and it talks about the complexities of editing considering that there isn't even full agreement on how to spell editing.
how to just spell editing.
Yeah.
Yeah. I'm going to say hi to a bunch of people. Hello to Andy Cowley, Bill Sugden, Cherry Catnaps, Eric Knapp, Frank Tippin, George Lancaster, Giselle Severin, Gordon Dewis, Guido Bibra, Ian Farquharan, Janelle Duncan, John Suffield, K Spence 303, Mad Science Workshopy, Magnus Timer Jensen. How am I doing, Magnus? Michael Mayer, Mrs. Nat, Mr. Tom Harbin, Ocean McIntyre, Paranor, Peter Wayoff, Pick and Duck, Rich Wilson, Ronald McCoy, Ryan Schmitz, Sean Kenny, Special Katana, Susie Murph, Thomas Tranneker, and Zap and Zap. And hey, everybody. So I have scheduled once again my next episode of The Guide to Space to begin the moment this episode of Astronomy Cast ends. So you'll have something to do after you finish watching Astronomy Cast. Join me for a live premiere of the new episode, all on Supernova 2006 GY. And
It is my favorite supernova, by the way. I just want to say
it's
that.
the
It's
more I
it's kind of
learned about this
amazing.
story, the more just absolutely incredible. I
So I have the
Is
paper
it an
flight to read
episode?
this
Let's do an
weekend.
episode.
Okay,
Okay.
but still, I have a question, and since you are already prepping your video, you may have already read more than I have. What was its remnant if it had one?
Uh, so so red giant, white
Hmm.
dwarf spiraled inside,
Right,
detonated.
got that far. Yes.
So when a white dwarf, full carbon burning, explodes as a Type 1a supernova, there is no remnant left behind. But it
Okay, so
wasn't
this.
enough power to explode the red giant. So it just kind of, blasted away chunks of it into space, and the shock waves from the explosion rammed into the into the layers that the star had been sloughing off because it had a white dwarf going around inside of it. And so there's still a red giant there, probably, and the white dwarf is gone, but it, it exploded from within, which is just crazy. So here, let's, can we look, so anyway, we got to wrap this up at 1 o'clock or whatever future time it is for you. But before we do, so maybe we'll make this Supernova 2006 GY next week because it's in my head, it's in your head.
Yeah.
But this has got to be an episode 2, and I'm going to share this picture, and of course, I think you're going to know what I'm talking about. Just even before we do an episode here.
Oh, yeah. Now, have you seen the animated version of that?
Yes. Yeah.
Okay.
Yeah, I don't know if I have the animated version on Universe
for people
today.
who don't know, those cells are the size of either Texas or France.
Yeah. Just
Texas
incredible.
is ever so slightly bigger than France.
Yeah. And people, it looks like popcorn. It's just gorgeous. It's such an amazing picture. And I love First Light. And this is one of the most surprisingly great first lights that I have seen in a long time. So
yes.
I don't know if that's an episode, but what an incredible image. And of course, people are just absolutely excited and loving this new news.
Doing an update on solar granulation and our understanding of the surface layer of the sun is probably something we can do.
Sure. Yeah.
Because we haven't done it in ages.
Yeah. So maybe the surface of the sun. There you go.
Yeah.
All right. So Susie, if you're paying attention, next week, Supernova 2006 GY, and the week after that, the surface of the sun.
And if Susie isn't in chat, can someone please add her with that? Because I will not remember.
Yeah, I know. Neither will I. This is... all right, so if you're wondering what it is that you've stumbled into, this is going to be a live episode of Astronomy Cast. We're going to be talking about red dwarfs and whether they are good or bad places to live. And I think this is going to be a lot of fun, because if there's been a topic that has just flipped and flopped back and forth for literally the length of time that we've been doing this episode, this is it. So stay tuned, everybody. All right. Let me know when you are ready to press record.
Okay. I am pressing record, and it said, no, you must give me a file name.
I don't even press record when I say we're going to press record. I just wait.
I know. This is episode what?
This is 557.
57. Okay. I'm now recording.
I'm also recording
now.
Okay. Here we go. Astronomy Cast, episode 557, Red Dwarfs, Friends or Foes? Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I'm doing great. I'm really excited about this topic. We'll talk about it in 1 second. But before we did, I just want to give a huge congratulations again to you and all the folks of the CosmoQuest community for all the work done with mapping out asteroid Bennu. OSIRIS-REx took more close-up pictures of Bennu from an even closer altitude. That place is just, it's all rocks. How did anybody get all that done?
I think I've mentioned this before. We all have been traumatized by the rocks. And I found out while traveling with a couple of the CosmoQuest crew members that if you say Bennu, it's like a call and response where someone responds F Bennu, and someone else is like, so many rocks.
Yeah, I see that in the chat right now. So my point of this is, one, congratulating everybody who was involved in the project for doing such an enormous amount of incredible and useful science. You helped make this happen. And for those of you who are like, wait a minute, I can help make something like that happen. How can people get involved in future science projects like this?
So we have a whole lot of ways that you can get involved. One of the things that we're doing right now is, since we don't have any really time serious citizen science, we're doing a complete rebuild to make sure that we upgrade all of our privacy and informed consent check boxes so that people know exactly what they're consenting for us to do with their data.
You will
Your
become sick
data
of
will be
rocks. Check.
published.
I agree.
Exactly.
Yeah.
So if you want to help, join us on GitHub. CosmoQuest team, CSB7 is the repository, and I'm hoping to start deploying bit by bit our new home in the coming months, starting with a yes, I consent to have
Yeah.
my real life name used in
Yeah.
publications, moving through to generating new science with new worlds.
Yeah, I
So
mean,
join us.
the dream has always been that we can help build this platform that people can come who want to participate in science and actually, without having to go and get the pesky planetary science degree, and can actually help out and get their name on a paper, and it's all coming together. So, I hope that everybody listening is as proud of you as I am for what you've accomplished with this incredible project and all the people who've worked on it. And I encourage everybody to go to cosmoquest.org to sign up. In one of the quiet times when people can hang out and have contemplative conversations, and you can look into the glassy-eyed stare of the people who've seen things. They've seen rocks. And,
Join us on
prepare yourself
Discord.
for the future.
Yeah,
Yeah.
share the memes, share the dialogues, and let's contemplate throwing rocks back at Bennu.
Yeah. Many hands make light work. On the one hand, red dwarfs are the longest lived stars in the universe, the perfect place for life to hang out for trillions of years. And on the other hand, they're tempestuous little balls of plasma hurling out catastrophic flares that could wipe away life. Are they good or bad places to live? That was not a rhetorical question, Pamela. Tell me, are they good or bad places to live?
It depends on exactly how old they are, and
Okay.
how much you want to live a nice, easy life.
Right. So,
I
okay.
think this is, yeah,
It's
we need to start
complicated
with
answer. All right.
what
Well, let's
is
dig into
it?
it. Okay. So,
Yeah.
first, what is a red dwarf?
A red dwarf is a tiny star. We're talking these things are on average at least 40% the size of the sun, if not smaller. They do come a bit larger. And in fact, there's a lot of argument over exactly where you draw the line at the top of what the size of a red dwarf is. At the bottom, these are the smallest objects capable of prolonged hydrogen burning via the proton proton chain deep in their core. They are that thing just bigger than a brown dwarf. And what's kind of amazing is the way these things process material. They're effectively convecting just like a giant spherical lava lamp. And in the process, they're mixing up their entire planetary, not planetary, they're mixing up their entire stellar atmosphere all the time. So all they ever do is burn hydrogen. And they're able to basically burn through all their
Right.
hydrogen over trillions of
Right.
years.
So they are both slow and in at the rate that they consume the fuel in them, and they are also very efficient because they're constantly mixing, and they're using every part of themselves, so that when, I guess, a red dwarf finally runs out of fuel, there's effectively no hydrogen left. He used it all up.
And they just sort of go, sigh. And instead of like doing anything dramatic, instead of having a red giant phase or anything else that a bigger star might do, they just sort of like collapse down to a tiny little white dwarf, and they hang out unless they have a binary star that offers them the potential to like do something dramatic. But because they're so long lived, the only hope they have of doing something dramatic is to be captured into a binary late in life.
Right.
Like one growing up on its own, there's no
Right.
drama except when it's a baby star.
And so that efficient use of fuel, that slower use of fuel, these things live, as you say, for trillions of years. So I think we can put that into the good category. More
Yes.
time, more better. So how are they bad?
Well, so we have three things working against us with them. The least worrisome I'm going to go with is they're super cool.
Mm-hmm.
So they don't have that big of a habitable zone. And that habitable zone they have is snuggled up super close to the star. So you have to be in exactly the right place in order to have a nice
Right.
temperate climate.
And it's a little
Now,
worse than that because, I mean, it is a habitable zone in that it is warm enough that your water, that you can have liquid water on your planet, but they're bad photons,
oh
right?
yeah.
They're red. They're far to the red end of the spectrum. So I don't know if you had read this. I saw calculations. Someone was saying that they have just a fraction of just the total usable. Like if there's photosynthesis on a red dwarf world, they have a fraction of the amount of just available energy that plants have here on Earth. Even though it's still, thanks to infrared, it's still warm enough that the water is liquid, but it's this feeble, terrible
So the
photons.
way to think of it is the light that you're dealing with is equivalent of being deep underwater. And so just like some deep underwater plants have to adapt to deal with none of the happy, bright, whiter colored, or I guess bluer colored wavelengths, even at the very surface of a world going around a red dwarf, you're going to be subjected to those very red colors.
Yeah,
Now, the problem is that's not all you're being subjected to. So,
right.
problem two with
That's like
these
the
suckers
least of your
is
problems.
yeah, we're starting with the least of your problems and working our way worse and worse.
Yeah.
So, if you are that close to your star, any lack of roundness in your planet shape is going to cause you to become tidally locked to your star. So the same face of your planet is always facing your star. So here I'm going to do a turtle turtle interaction because I have turtles. So here we have large lava turtle pretending to be a star.
Uh,
So
For the podcast listeners, Pamela is holding a turtle made of lava.
and then here we have a small porcelain turtle that will be our planet. Now, clearly, planet Turtle is not a circle. It is not a sphere. It is not symmetrical. And this means that if it's trying to rotate about the center of its shell, every time the excess mass that represents its head goes past, it's going to get pulled back. A torque is going to get exerted, trying to slow its rotation as it goes past, and it accelerates its rotation as it gets toward. And so it will eventually settle in so that as it goes around our star, that head of the turtle, our gravitational extra bit, stays pointed at its star. Now, planets aren't as asymmetric as turtles,
Right. But
but
still.
they're asymmetric,
Right. And
which means,
we're all familiar with this process here in the solar system with the moon.
yeah.
The moon only shows us one face. All of the major moons around Jupiter only show Jupiter one face. All the major moons around Saturn only show Saturn one face. So this concept of tidal locking is inevitable for objects close to each other like this. But
And
is that super bad?
so this is where when you say friend or foe, frenemy is a thing.
Sure.
And we have a nice, friendly star. We're able to maintain a day night cycle, which really helps with the thermodynamics of things around here. Our daytime side of the planet, it does cool down at night, and this does help drive weather patterns. But overall, it's not that severe. We can all survive the jet stream, and life is pretty good. Now, if you're tidally locked, one side of your world is going to get dramatically heated up. The other side is not, except through thermodynamic processes that carry heat from one side to the other side, by which I mean wind.
Right, right.
And so these worlds are going to have extraordinarily powerful winds. And depending on the ratio of what they're made of, so a lot of these worlds, it turns out, are actually like 10% water
Hmm.
from what we're detecting. So you're going to have high humidity, moist worlds with massive water that's going to have massive circulation in the water, massive circulation in the atmosphere. And models are showing that it should be possible to have a climate that's survivable.
Yeah, yeah.
But you're living in a hurricane.
Yeah, I mean, I think originally the idea was one side is a parched, baked death desert. The other side is completely frozen, and there is this thin little area right at the edges of the planet that are maybe livable. But there was a fascinating new series of climate research that came out of NASA. Did you see these simulations that they did of Proxima Centauri B? So they actually
That one I
ran,
haven't seen.
yeah, they ran planetary simulations of just what the environment would be like on Proxima Centauri. And what you ended up with was that the near side is a lot more like a jungle. You get a lot of evaporation, you get a lot of clouds, you definitely have winds that's pulling that temperature around to the far side. But in fact, the whole side that faces the star is probably very habitable. And then it's on the backside, it's something that's very icy, but it's not, it's like Antarctica bad, not never sees the light of the sun bad. And you get this transfer of energy that's coming from the back to the front, but also the ice, the cold side is helping to regulate the temperature on the front. And so it would be more like you're living in a constant jungle on half of the planet, and various variations as you get closer
But
and
with
closer to the
very
sides.
limited surface. I mean,
Well, it
10%
depends,
water
yeah.
by mass.
Oh yeah, that's a water world,
Yeah,
right?
and they're finding that a lot of these worlds appear to have densities consistent with 10% water by mass.
Yeah.
So yeah, water world with like nasty churned icebergs and hot water at the hot spot, and it's it's gnarly out
Yeah,
there.
the like I said, these simulations, they took Earth's continents, they took Waterworld versions, and those really beautiful simulations that show all the cool, almost looks like an abstract painting with all the little currents, and they did
Yes.
that, but for Proxima Centauri. It's a absolutely fascinating sort of simulation. It's possible we have a story about this on Universe Today. Um,
And we have forgotten to mention that that star closest to the planet Earth, Proxima Centauri, as we've been implying without actually saying, is a red dwarf.
yeah,
Red dwarfs are, by the numbers, the most common kind of star out
yeah.
there. So figuring out if they can support life is figuring out if the most common kind of star out there is capable of supporting life.
All right, so just for people who are keeping track right now, the first one seems bad, but we have plants that can handle being underwater. The second one seemed bad in the beginning, but now maybe it's not quite so bad. We've got sort of two things that
I'm
are
gonna go with it's difficult.
difficult, doesn't mean impossible. So let's
Yes.
go to the worst problem. This one could
Yeah.
be a deal killer.
So, for the first billion years or so, during that period of time when planets are forming, when life is starting, when all the chemistry of building your atmosphere is taking place, during this long, important, early developmental phase in a solar system. Red dwarfs just aren't having it. And they are undergoing massive magnetic field rearranging events that are capable of removing entire atmospheres in one foul magnetic
Yeah.
flare
Yeah,
outburst.
if you take like the worst possible flare that the sun can do, red dwarfs can do flares which are 100,000 times more powerful.
In the far infrared, sorry, in the far ultraviolet, they will undergo flares where their ultraviolet light, this is like ionizing light here, folks, is 193 times brighter than normal. And
Yeah.
it only does this for like half an hour.
Yeah. And it can
But
do
that's
these,
one bad
yeah.
half an hour.
And it can do these multiple times a day. So you've got flares potentially releasing, you know, many more times the amount of energy than the sun ever gives off, and it's doing it all the time. And each one of these events would easily scour away the ozone layer from planet Earth, would take the atmosphere and take it off to space with it. And you've got these things happening all the time, and this seems to be a really common occurrence for these red dwarf stars.
There's a team at Arizona State University that have been doing a survey with the Hubble Space Telescope that is called the Habitable Zones and M Dwarf Activity Across Time Survey, which is one of those forged together acronyms because the way they abbreviate it, it's the hazmat survey.
Right.
And they're just trying to figure out just how bad is it out there. And they're finding like you said, it's 100 to 1,000 times more powerful than anything that we have experienced here on Earth.
Yeah.
And so now you're looking at a picture where during that first billion years, all of the nearby parts of these solar systems is getting irradiated,
Yeah.
blasted, atmospheres are getting removed. And so you have to figure out after the stars calmed down and settled into a more beneficial lifestyle, you have to figure out how to either migrate healthy planets inward,
Yeah.
or you have to figure out how to repopulate these inner worlds with volatiles.
Yeah.
We know this happens because we're seeing
Right.
things, like I said, that are consistent with them being 10% water by mass.
So they get water. Yeah.
They get water. But the question becomes, how then does life start? How does this happen? Is
Yeah.
We
I mean,
don't know.
so there was some recent research that showed, in fact, just how bad these flares are. They are pushing material out of the inner solar system like a snowplow. And you can actually see these flares and the coronal mass ejections and the material that is flowing out of the red dwarf. And it is like blobs of material just getting shoved out into deep space. And so, as you said, right, you start with this nice, perfect environment. And the analogy that I
Yeah.
like to use is like you go to the store and you buy a dozen eggs and you set it on your table and you hammer it for an hour. And then you wonder how many chickens you're going to have, right?
You
Because
know, if you're buying eggs capable of producing chickens, you have a different problem to deal with.
so 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 it is like it is a just a terrible place in the beginning. And
Yeah.
so then but then we know that solar systems have a tendency to move things around. And as
Yeah.
you said, if they have all that water, then it came back.
And so we just don't know what is the composition, what is the viability, can you form life late in the solar system? If you can form life in a solar system, why don't we still have new forms of life forming on Earth? Well, probably because other things already ate those ecological
Because they were
niches.
tasty.
but but this sort of changes. It's like yet a new ugly way to have to figure out how to form life, and we're struggling to figure out how we got here in our nice friendly solar system.
Yeah.
So it's complicated out there.
Yeah.
It's really complicated.
So what do you think then is like the best case scenario
Wait,
here?
I lost.
Did you catch that?
So yeah, I had a glitch for a minute. Um, so best case scenario is after the star is done doing its "I shall irradiate
Yeah.
all of you"
Yeah. You had your little
first billion
tantrum.
years
Yeah.
or longer, depending on its mass. How long it does this depends. Uh, that somehow you end up with material infalling until it settles into new orbits within the habitable zone. Now, an object further out isn't necessarily going to be tidally locked. The further out you are, the less likely you are to be tidally locked. So, conceivably, you could have something spiraling in, getting angular momentum as it goes, grabbing it up from material it encounters, and starting out in that habitable zone with some rotation and a friendlier environment for life to get started. And as that world slows down, just as our own Earth is slowing down, but in a much more dramatic fashion, um, life takes hold and is able to continue evolving and changing to meet the special awfulness
Right.
that is this kind of a situation.
Yeah, I mean, if you dropped various forms of Earth life into that environment, I'm sure if we just dumped cyanobacteria onto a world like that was warm, that had water, that was receiving some amount of sunlight, it would find a way. It would survive that kind of environment. So,
And and the best hope is life starting as we think could have happened here on Earth around a subsea volcano of some sort and then evolving to meet the different and easier in some ways to survive environment with more and more sunlight towards the surface of the water.
it's kind of a fascinating concept to think about this idea that maybe the life did form around these volcanic vents, and then you've got, say, 100 kilometers of water above you,
Yeah.
and it's just an impossible gulf. And maybe there could be some advanced civilization that grows up in this environment, and their
So
idea
much
of
pressure.
space exploration is to go higher and higher up through the water. That they're as far as they've reached 10 kilometers above their where they live, and their astronauts are trying to make their way up to the surface. And think
Yeah.
about their concept if they could reach the surface and look out into space and see the stars and realize that that they're in a much wider universe than they had ever thought. It's kind of a romantic notion. All right, well, that's your best case scenario. So flip it around. Hit us with your worst case scenario.
So worst case is every time life starts to take hold on one of these migrated in worlds, it gets blasted again with this radiation. That the water that comes in from infalling objects is just the nastiest water out there, and it has the wrong ratios of chemicals to allow life, that everything is a special disaster of perchlorates. I don't know if that's a thing, but well, I know
Right.
perchlorates are a thing. I
Right,
don't
but
know
you've got all
if
this
comet rays are.
ultraviolet slamming into the top of the water,
Right.
poisoning it down below.
Yeah. And we don't know if our environmental models are correct. Now, imagine that as the world freezes, it ends up with some sort of a weird teardrop shape on the other side. That could create all sorts of weird eddies and patterns in the wind. There's so much we don't know. We can't even fully deal with the our own weather here on the planet Earth. How do we expect to be able to define the exact habitability of the environment of a planet that's tidally locked, snuggled up next to a star that has some sort of a weird chemical mixture in its atmosphere. And the reason I say it probably has a weird chemical mixture is after being blasted that much and not rotating, what kind of a magnetic field is it going to have? It's going to have an atmosphere of thick molecules.
Yeah.
So if you have life, it's probably going to have to be in that water because you're not going to have an atmosphere that's necessarily breathable or thick.
And it's times like this when I get sad that probably not in our lifetime will we see photographs of what these worlds would look like up close. We might have some hints of some ideas that, oh, Proxima Centauri, the best super duper telescope, told us that it's probably got a surface that's mostly water.
I love the fact that you qualified that though and said probably not
Probably.
in our
Yeah.
lifetimes. I am content to say we are not in our lifetimes going to see
Yeah.
photos of the
But
surfaces
we all
of,
know
of...
that I'm going to have multiple robot bodies. So,
That's true.
yeah.
That's true.
But, so, the jury's out. Friend or enemy?
Frenemy.
Frenemy it is.
It's complicated.
It's complicated. Well, thanks, Pamela. Do you have some names for us this week?
I do. I would like to thank for making this possible through their patronage over on patreon.com/astronomycast the following excellent human beings: Bruno Letts, Marco Arosi, Matt Rucker, Brian Gregory, Brian Kilby, Jessica Phelps, William Lauer, J. Alex Anderson, Brent Krynop, Omar Del Riviero, Tim Garish, Dustin Rolfe, Arthur Latz Hall, Joe Wilkinson, Mark, Stephen Raznak, Chad Callipy, Jeremy Kerwin, William Andrews, Neuter Dude, Claudia Mastrani, Frederick Sjorg, Paul Hayden, Joshua Pearson, and Jack.
Right on. Thank you, everyone, for your generous support to help make Astronomy Cast even happen. Susie appreciates the salary that she gets, and the server appreciates the electricity that it receives. All right, everyone. Pamela, we'll see you next week.
Bye-bye. Now stay. We're just saving.
Yeah, we're not talking about you. We'll see you right now.
Yeah. We are seeing you right now.
557. Okay.
Okay.
Export my audio. Save it as a wave. Okay. Special Katana became a patron to my channel yesterday. Woo! I know, I've got some information coming for you, Special Katana. Thank you so much. All right, so we've got about 18 minutes before we wrap up the show, and then you're going to want to switch to watch the new episode of The Guide to Space, all about supernova.
Oh, you're doing a premiere again?
Yeah, 2006 GY. So I used to release my episodes at 12 o'clock on Fridays, but during the summer while we weren't doing Astronomy Cast, but now because Astronomy Cast is back, I'm shifting it to 1. So I may shift all of them to 1. I'm not sure. So that way, hopefully someone can put a link into the show notes of the premiere, so you can come and join me for that. It's short, 10 minutes. It's not long. I'll be there. We'll chat.
I have a telecon.
Yeah, no, it's fine. I don't even watch my own shows. All right, so Arjun asks, how many classes of star are there between red dwarfs and a star like the sun?
O, B, A, fine girl. G for our star.
Yeah.
Kiss me is the horrible misogynistic way they teach us to remember all of the star types. M and K are the red dwarfs.
Yeah.
So they're the ones just below us.
And K are like the nice one.
Ks are the nice ones,
Yeah.
and not all K stars are considered red dwarfs.
Yeah. In fact, it's considered that the K stars are probably the best stars in the universe because they're the longest lasting, but they're not temperamental. And so,
Well, the M's are longer lasting, but the K's are
yeah,
not temperamental.
right. The Ks are like 80 billion years,
Yeah.
right?
Yeah.
As opposed to 10 trillion, but they don't go through that
Right.
horrible temperamental stage at the beginning. So, Michael Meyer asks, might perchlorates be a good source of energy for a suitably adapted type of life?
I have no idea. As far as I know, they generally are responsible for killing things.
Yeah, but I wonder if you can get energy. I mean, like generally you need hydrogen for energy. So what's in perchlorate?
It's going to
Hydrogen
have
perchlorate,
hydrogen.
right?
Yeah.
So what's the actual chemical symbol?
Hold on.
Perchlorate salts are chlorine and oxygen. So you're not going to get any energy out of that. But will it be bound up with something like hydrogen? You're going to get ammonium perchlorate, which has nitrogen, hydrogen. So there's some hydrogen. You got perchloric acid, which is some hydrogen. You've got some potassium perchlorate, which I don't know if that's going to do the trick for you, and sodium perchlorate. So again, a problem there. But if you've got ammonium perchlorate or perchloric acid, that might do the trick for you. But I am not a biochemist. So,
And there's ammonium perchlorate is a kind of fuel.
so there you go.
Um,
Yeah. So if an ammonium perchlorate
yeah,
can
it's used in
form,
rockets.
yeah,
Yeah, it's solid rocket fuel. So yes, you can turn this into solid rocket fuel. It just required a different form of googling.
right. And so then I guess the question is, will that form naturally, and would you be able to eat rocket fuel? You know,
Well, you
life
can't eat
life
it.
finds a way. Uh, so let's see. So Michael Mayer also asks, life on Earth didn't start in the first billion years. How bad are flares after that? Maybe you just want to live on the cold side of the Terminator initially. That's an interesting idea. Huh. So you like hide behind the
So billion is best case. In a lot of cases, for the smaller stars, it can be 5 billion years.
yeah.
Um, so there's also the issue of they're flaring so badly, your whole atmosphere goes bye bye, like all of it.
Yeah.
No more atmosphere.
Right.
Goodbye.
But it comes back.
The question is, when you have flares that big, how much volatiles do you have left to come back?
Right. Well, I mean, again, this is the 10 trillion
Okay.
year question.
Yeah.
And this is just, I mean, can confirm planets exist around red
Yes.
dwarf stars. So we know that they are not snow plowed out of the solar systems entirely. They survive. It's believed that they have a much higher percentage of water than places like the Earth. So there is volatiles coming back home after the destructive phase. So then it's just a matter of how much to what in what time period. Yeah. Yeah, it's interesting. We just don't know. We don't know. I mean, we just found planets. Give people
Give us
give
time,
them some
people.
time. Arcatufus asks on Twitch, people think that it's weird that our solar system does not have a super Earth. Could it be that Earth starts as a super Earth but shrinks because it got knocked off to form the moon?
So the total amount of mass on that doesn't work. As near as we can tell, in order for the moon to have been formed, you would have needed the collision between a proto Earth and an object roughly the size of Mars, which means that our earlier Earth was smaller than the one that we
Right.
have now. So when you take the moon's amount of mass, the Earth's amount of mass, subtract off Mars' amount of mass, you get a smaller early Earth. So,
Right.
yeah.
So you want like, I mean, a super Earth is going to have 3 times, 5 times, 10 times the mass of the Earth. So you need more Earths. And the moon doesn't
And
have
we're
enough.
still trying to figure out why different size objects form in different places. And they are finding super Earths on a regular basis around these red dwarfs. So
Yeah.
we don't know what causes different systems to have different sized worlds.
Unc Willie is asking, how broad would the habitable zone be?
I should know that, and I
Yeah.
don't. I know it's smaller than our habitable zone,
Yeah.
which goes roughly from Venus to Mars. It's significantly smaller, but they're still capable of cramming multiple worlds within that distance, as has happened with the TRAPPIST 1 system. And we're both now Googling.
Yeah, we are. Yeah, sorry. I'm looking for some research that explains it. So it's funny to me that when scientists do work and figure out some really interesting things about some astronomical feature, they don't put in the most interesting parts to
Yeah.
the lay public. Like, for example, when you find out about supernova 2006 GY and how this white dwarf spiraled into the red dwarf, a question that might pop into your mind is, how long did it take? Right? How long did
Yeah.
that process? How long was the white dwarf? It was tough for me to find that information. It took 100 years. So, yeah,
Yeah.
I don't
I'm
see an
looking
easy
at an
answer.
image that I don't think is right.
Yeah, so I don't see an easy answer to the question. I apologize.
Sorry.
Let's see. John Suffield is noting a good book to read is Hot House by Brian Aldiss. Billions of years in the future, Earth is tidally locked to the sun. No spoilers, but highly recommended sci-fi. Awesome.
Cool.
Thank you. And Arjone asks, would the weak gravity of a red dwarf allow for more infalling comets to replenish volatiles over time?
So the psi is there's also a matter of angular momentum. So how do you shift something's angular momentum? It will be significantly easier within a lower gravity system. Um, you don't have to be as far away for comets to form. I think it would be easier, but the volume available to
Right.
form comets is a much smaller volume of space.
Right. So you've got a smaller star, smaller planets, smaller Oort cloud,
Yeah.
smaller Kuiper belt. Everything is less. It's just a scaled down version of what we
Yeah.
would see in our own solar system. But you would still get it moving through nearby relatively other stars. They would cause, permutations in the orbits of the comets.
Yeah.
They would fall in to the inner solar system and crash into the planets and deliver volatiles.
And again, we are finding super Earths that appear to be 10% water by mass,
Yeah,
potentially. I mean, we
potentially,
could have our
allegedly.
models completely wrong, but that's what it's looking like.
Yeah, yeah. So I mean, these are all key questions, right? That need
Yeah.
to get answered. If only there was a satellite that could be launched that would characterize exoplanets and their atmospheres, like Chaos that just took off its lens cap, like yesterday or 2 days
So
ago.
we'll just have to wait and see.
Yeah, yeah, yeah. I mean,
Did you see the General Office of Accountability report in JWST?
yes, July.
So 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 they are saying there's going to be delayed launch.
Yep,
It's going to be even more over budget.
yep.
There are 300 single points of failure. There are over 500 faulty bolts.
Faulty or
And
just bolts that are potential, like they're potential places of failure, not that they are faulty, right?
there are some mismanufactured bolts.
Okay.
And And they found along the way that there had been one fin installed backwards. That got fixed.
Good. Good.
But yeah, our own Binary Blaze, Annie Wilson, did a rage read of it so that not all of us have to.
Oh, that's so good. Yeah,
So she tweeted about it. Check it out, Binary Blaze on Twitter.
that's amazing. I mean, it was should have been March. Now it's probably going to be
It should have
July.
been 2010.
Sure. Sure. Yeah, but
Spitzer was supposed to have a 5 to 6 year lifespan so that it could be replaced with JWST.
it,
They made Spitzer keep going for
oh,
16 years while its batteries
oh,
died.
poor Spitzer. Why
And
that spacecraft was I just wanted to retire, but they just wouldn't let it. Um, yeah, I mean, like, this does not surprise me. In fact, I kind of had some advance warning that this was going to happen, but I had to sit on it. But like, it's like an extra 3 4 months. You won't even notice, right? That's nothing.
see, I forget who it was. I want to say it was Michael Brown, the planet hunter, um, who recently said that it's always 16 months away.
it's it's like fusion, right? Yeah.
Yes.
Yeah. I mean, and like, I mean, this is of course back to the sunk cost fallacy, right? Which is that
Yeah.
here we are, it's pretty much done. Sure, there was a couple of bolts that need to be replaced. A fin maybe should go the other way, um, and then it needs to be folded up nice and tight, put on a boat, and sent to Kauru in French Guiana, where it will be launched. And it's going to take many months in French Guiana to be mated to the rocket and run through more testing, et cetera, et cetera, et cetera. And so it's understandable that it's going to cost an extra whatever, however many hundred millions that it's going to. But if the astronomical community had known at the beginning that this was not going to be the $3.2 billion telescope they were expecting, or the $1.4 billion telescope that they were expecting, but the $10 billion telescope that was going to arrive 10 years late, would
We would
they
have planned
would they
differently.
have even embarked upon this journey? And I think the answer is no way.
We would have done incremental improvements.
Yeah.
We
Yeah.
would have launched a successor to Spitzer that was more conservative
Yeah.
but advanced our abilities and
Yeah.
innovated in a rational way instead of saying we are going to invent entirely new
Yeah.
technologies and we're going to do it on time and on budget. That is not a rational decision to
I
make.
I think that James Webb will be the final large telescope that is launched and deployed in one mission. That from here on out they'll be constructed in space like the International Space Station. The you know, it looks like there are pretty good cost savings to just
I'd say it's
launch
the
them in
last
pieces.
fold up.
Yeah, the last.
Because if we get something like BFR, I mean,
Oh,
forget it. You don't have to fold the sucker, just launch.
you still do, right? Like even James Webb would require significant folding to
Yeah.
fit inside Starship. But you launch Starship, or you launch even on Falcon 9s carrying chunks, and then you
Yeah.
have the main satellite bus, and it's got a bunch of Canadian built robotic arms that are grabbing the pieces as they show up and bolting them together. You can build a really big, very powerful telescope for where if any one part goes long, you don't have to make it out of compact equipment. You can use larger, bulkier,
Yeah.
more cheaper supplies. They just have to fit in one rocket. And if your rocket launches only cost you $50 million per launch, plus whatever chunk you're firing up to space,
Yeah.
it looks like today the it's actually a very economical way to go about it. So Uncle Willie is saying, what about LUVOIR? It's entirely possible that LUVOIR will be constructed in space in pieces and not in
Okay.
one full launch. But it's also possible that it'll be in one full launch. So we're still kind of waiting to see what happens. But I'm pretty excited by this whole idea of the of these on-orbit construction, of assembly of telescopes.
And that's where we thought we would be by 2000 back in 1988. I remember seeing the diagrams for the construction hangars that were going to be built as part of Space Station Freedom, which eventually morphed into a much curtailed ISS.
Yeah, yeah. All right, we've reached the end of our hour, and like I said, you should join me for a live premiere of my episode all about Supernova 2006 GY, when a red dwarf ate a white dwarf. That'll be on my YouTube channel, so not here. But a huge thank you to everyone who watched us today, all of the moderators, all of the just the incredible community who join us every week to do these
Everyone
shows.
on YouTube and everyone on Twitch.
And Twitch too. Yeah, everyone's on YouTube, everyone's on Twitch. This is so cool. And of course, thank you to all the patrons who help make the show possible. All right, thanks everyone, and we'll see you all next week. And now you know what the topics are going to be.
It's true.
All right, thanks everybody.
Bye-bye.